Can you guys hear me all right? Do I need a microphone or is this loud enough? Cool. So I think we're going to go ahead and get started, and then we'll just let people keep trickling in. Okay, so the topic of our talk today is how we've built S3Tables support in Daft, and we'll talk a little bit about like the service itself, how it relates with Iceberg, and then like what Daft is and how Daft supports it. So first off, my name is Connor, and I'm a software engineer here at Eventual, and I'm presenting with ChanChan.
Yeah. Hi everybody, I'm ChanChan. I lead developer relations at Eventual.
So a little bit about myself. I live in Seattle, Washington, and I do lots of sports there, like cycling and climbing and skiing and stuff. And in 2019, I moved out to Seattle to work for Amazon. And I was at Amazon and actually until the start of this year. And so while I was there, I first worked in CloudWatch Logs on the Logs Insights query engine, which is a distributed query engine on like logging data. So it's like semi-structured stuff. And then I moved to a team called Particle, where I worked on the Particle query language, which is a SQL dialect with extensions for semi-structured and nested data. So like being able to write really nice SQL over JSON without just a bunch of UDFs, but actually like first-class clauses to working with JSON. It's quite nice. And it's in Redshift if anyone's ever used like the super type. It's kind of like variant and stuff. So I joined Eventual at the start of this year, where I work on SQL and our catalog integrations in particular. And so today I'll be talking about those catalog integrations and how we use that for S3Tables. And then as far as like my work interests and kind of what I like to focus on is SQL things, PL space, and I put DBMS architectures is generally love like reading about all the different like evolution of these services that often gets covered in like the introduction of many of these talks. But then also semi-structured data, like all the variant stuff was like very close to home, all of the like super type, all of the different formats, because it's not only JSON, there's also some other ones. All that stuff's very interesting to me.
Hi everybody, I'm ChanChan, and again, I lead developer relations at Eventual. I live in San Francisco, and I'm actually born and raised in the Bay Area, if any of you know where Foster City is. I started my DevRel journey at a startup called Aluxio, and that's where I was introduced to the open source community, and that's where I started learning about, what it really means to be a community evangelist and a community manager. And then I joined Eventual in August of last year, where now I focus on building a community around Daft, whether it's through organizing meetups around the Bay Area or getting involved with open source projects like Iceberg, and also just ensuring that our users and contributors have the support that they need. So today we have a jam-packed agenda for you guys. First, we're going to start off with an introduction to Daft and S3Tables. We're going to talk about what kind of problems S3Tables solve and go over some examples to show off why they're useful. And then we'll also talk about how S3Tables relates to Iceberg tables and then just how Daft fits into all of this. Cool. Then we're going to dive into how to actually set up and use S3Tables by following AWS's Getting Started documentation. And yes, we're going to run into some problems, especially for the Python community, but it's okay. We're going to walk through them together. And then once we've got our S3Tables set up, we're going to demonstrate how using S3Tables with Daft is actually really easy. And we'll show how you can read your data with Daft data frames, and then also how you can write to these tables. And then finally, we're going to share some challenges we faced with building Iceberg S3 support, share some learnings and how we're reducing the need for external dependencies, and also highlight our ongoing collaboration with AWS. And then after that, we'll open the floor for some Q&A. Okay, so to start, what is Daft? Daft is a unified engine for data engineering, analytics, and ML/AI. Daft exposes both SQL and Python data frame interfaces as first-class citizens, and it's written in Rust, so Rust and Python. So you get the speed, you get the performance, and you get the convenience. Daft is also designed for multimodal data workloads, so not only supporting tabular and structured data, but also supporting diverse data in all formats like text, images, and audio, for example, to serve teams that want to unlock new ML/AI capabilities. Locally, Daft is lightweight and extremely easy to use. You can just pip install Daft and it'll work right out of the box. And the magic of Daft is that on top of our great local experience, we can also seamlessly scale to petabyte scale distributed workloads. So Daft supports creating data frames from several data sources. We support reading in-memory data from like a Python dictionary, a PyArrow table, or a Pandas data frame, for example. We also support reading from files like Parquet, CSV, JSON, and also catalogs like Iceberg, but also Unity and Hootie. You can even create a Daft data frame through a RAID data set from a LanceDB table and even a SQL query. Cool. So Daft supports the Python data frame API with common operations like filtering rows, creating columns, joining data frames, sorting, grouping, aggregating. The list goes on. And another thing to point out is that Daft is lazy. So what that means is that Daft doesn't execute operations on a data frame immediately. Instead, it'll create an optimized query plan of its operations for more efficient computations and just to save time and computing resources. And then when you do want to execute, you can call a .show or a .collect, and then Daft will execute the operations and materialize the data frame. On top of supporting Python, we also support SQL, which can be more ergonomic than using data frames for writing queries. Our daft.sql function will automatically detect any Daft data frame objects to let you query them easily by name. And Daft SQL also supports expressions, so you can very easily and interchangeably use Python or SQL on your queries. Daft has a great local execution experience. You can get started with Daft very easily by doing a pip install Daft, and you don't need to install any dependencies to get Daft running. And then you can import Daft, create a data frame from a Python dictionary, and then you're able to start executing some common data frame operations. Daft's execution engine is built with push-based execution, Morsel parallelism, and streaming data flow for efficient use of memory and compute resources. And that was a lot of buzzwords. So if any of you guys have questions or are interested to learn more about how we actually built our execution engine, you should stop by our booth on the 3rd floor later, and you can talk to our engineer, Colin, who actually worked on building the Daft engine. Okay, and finally, Daft has great distributed execution as well. So say you're writing an ETL job, you're likely querying and testing that on your local machine and not running these tests on a distributed cluster. But when you want to scale to larger workloads, you want an engine that can do that as well. Instead of relying on separate stacks for local and then distributed execution, that just creates unnecessary complexities and like a really fragmented developer experience. So with Daft, you have a single engine that can do both. You can seamlessly transition from single node local execution to also multi-node distributed execution by starting a RAID cluster. Great, so that was an overview of Daft. Now I'm gonna pass it off to Connor to talk about what is or what are S3 tables.
Cool. Thank you, ChanChan. Okay, so yeah, this slide says what is our S3 tables. There's S3 tables, the service. There's also S3 tables, the tables, and we're gonna unpack this. So yeah, first of all, S3 tables is a new service from AWS. This was announced, I think, December 4th, so the very end of last year. And it's offered alongside S3 storage. So you actually have a new bucket type. When you go create a bucket, you create a table bucket. And this will give you a special bucket optimized for OLAP stuff. The cool thing that I think is really cool is you have these automatic maintenance jobs. And so you'll get managed compaction for you, which has like really strong implications for read performance, which is exciting, as well as it just simplifies things. And then S3 tables supports Apache Iceberg tables. And we'll dive into like what exactly it means to support Iceberg tables and why S3 tables might be slightly different than an Iceberg table themselves. And then an important thing is that the S3 tables API that you get like with the AWS SDK is not Iceberg REST. It's like its own thing, and it's just one of the SDK libraries. But there's actually a bit more going on here, and there have been some developments, and so some of you may already know all this stuff, but we'll unpack it. And then what problems does S3Table solve, and like why would I use this new service versus like my own S3 bucket? Well, primarily it like reduces complexity. So you don't have to host your own like catalog service on top of this S3 bucket. It is the catalog service for you. The other thing is you now have like access control where you can do your normal things with like S3 key prefixes and IAM policies, but you can integrate with other AWS services like Lake Formation. There's also SageMaker Lakehouse. There's various ones, but the point is all of these have like different access control mechanisms, like restricting and scoping access to catalogs or namespaces or particular tables. The other thing, like I was saying, is S3 tables are decoupled from the table format themselves. So today, like I was saying, it's like a little strange. They're, Iceberg tables or supports Iceberg. But technically, an S3 table is kind of parameterized on the format, and we'll see what that looks like. And then finally, S3 tables make it very easy to integrate with other AWS services because you don't have to set up all like the glue stuff yourself and tell it like, hey, this is my bucket, this is what it's all like. Instead, you create a table bucket, you create a table, which is, Iceberg, and by checking a few boxes, then like Redshift is able to access that, Glue is able to access that, Lake Formation, SageMaker, Lakehouse, Athena, yeah. And so it makes integrations with the different services very easy. So then, how is it all related? Because I work at Eventual, I work on Daft, and we're talking about this new Amazon service. Well, Daft is like ChanChan was saying, it's an execution engine, and then S3Tables is a service. That service is then backed by like our actual file structure, which is Iceberg, and then ultimately we have a bunch of S3 objects. So show how this all relates. Well, first off, let's step back and what is an Iceberg table? An Iceberg table is it's a very clever way to group a bunch of data files. At the end of the day, we just have a bunch of Parquet files in a bucket, and then we actually have to connect all of this and figure out what belongs in this table, what may be deleted, what may be changed. And so there's this thing up here, this is kind of what Ryan was talking about, how, it's a little bit complicated, but we have this, what's called the metadata layer, and that just tracks, what belongs in here. The most important thing, though, is at the very top, and that's the root, and that's the entry point, which tells us, this is how you actually follow the arrows and collect all of these data files. So if we want to read it, we pick which one we want, usually the latest, and we can go down and list our data files. But when we want to write this data, we actually go the opposite direction. So you run your computation, you produce new data files, you produce new Parquet files, you put those to S3, and then you have to update this metadata layer. And this is where a lot of these implementations and these libraries come in handy because that can be complicated. Okay, but at the end of the day, these are all just S3 objects. And so there's just gonna be a bunch of put object calls. So then what is an S3 table more precisely? And so what I said is S3 table is just like a name that we assign to a logical group of these data files that's stored somewhere. And then if we're talking about an S3 table being a logical thing, then we could say that Iceberg is the physical format of this data. It's actually the description of how these bytes are stored or how these files are stored. So because Iceberg is the storage format, we should just be able to use all of our existing Iceberg tooling. But I say this is kind of where the story begins because the S3 table service introduces a layer over the top of it, which we have to work through. So how is it all related? Well, Daft, when you say, select star from T, it goes to the S3 table service to say, well, what is T? I give you a name, please map that to a metadata file. Please map that to my actual physical bytes. And then Iceberg tells us how to find all of it. And then at the end of the day, it maps us to a bunch of S3 keys, and we start calling getObject. So then now what I'm going to do is I'll walk through getting started so we can set this whole thing up, and we'll show an example of the full flow of going through that. But we're going to work through the timeline from the beginning because things actually have recently changed, and I've updated this, and we'll cover that. So when it was announced back in December, they released this getting started document, and we'll just kind of go through that. The first thing is, like I said, we need to create a table bucket. It's different than creating a bucket. You'll see we call it the AWS CLI, and there's this new service. It's not AWS S3 create bucket, it's S3Tables create table bucket. And I'm creating one here, and I've just named it pond in US West 2, and that will give you back the ARN. The ARN just gets reused every time you call one of these APIs. Then we'll create a namespace somewhere to place our table, and this is like very familiar. Like if you use Iceberg catalogs, create namespaces, what you do before creating a table. And I'll just create a namespace called demo. So you'll see these APIs are very, very familiar. Okay, so then again, just like with a Iceberg catalog, we have create table, and then create table takes some DDL, and I'll show you what's in this JSON file because this is where things get a little bit more complicated, and I don't want to show that it's a bunch of arguments. And so this is what that request looks like, and we can see Iceberg in a couple places here. The first thing is we'll see Iceberg as the format. So that's kind of what I meant by like the S3 table is not coupled to the storage format. You can parameterize it here. And then if we look back at the metadata, we'll see we provided an Iceberg schema. So we have our like column names, but then also our Iceberg types. That way we don't have this like amalgamation of some like minimal common set of types across all table formats. Instead, you can, specify your types for your format. Okay, cool. So I have a bucket. So now I should technically have a whole Iceberg catalog or an S3Tables catalog. And I've created a namespace, created a table, and now I want to upload my Parquet file. Ultimately, my goal by the end of this presentation is I've uploaded my Parquet file, and then I can read it back. So we'll call S3Tables insert into, I'll give it that ARN, and then I'll give it the file. But this is actually going to give us an error, and it's an invalid operation. And so there's no such thing as like a put object call here, because like we were saying, writes are a bit more complicated. So if we go like look at what's available to us, we'll see that all of these are just like a Iceberg catalog API. There's like listing namespaces, listing tables, there's putting, renaming, whatever. All of these are kind of metadata operations. None of them are actually like data operations. So if we go back to like getting started, like how does it tell you to do this? And the tutorial for this is actually a little bit vague. So it says there are many different ways we can do this, and then it says for testing purposes, I quote, use Spark with different command line arguments, but the tutorial didn't actually provide what these arguments are and how to kind of set this thing up. And it was actually it was non-trivial to get to this point. So I actually went through like several different tutorials to try to figure this out, some not even from AWS, and then also like had some long conversations with ChatGPT, and I got some arguments, and I kind of ended up here. But what we notice is when we run the Spark shell, we have to have this like special S3Tables runtime jar, which like has some like special logic for handling actually like being able to write this data, because like I said, there's this layer over the top of our Iceberg table that is not an Iceberg catalog. It's this AWS service. And so that jar has the logic to kind of shim these calls, but again, like this is new tooling when like I just have Iceberg bytes like in a bucket, so I should be able to use it. The other thing is I was like plagued by a bunch of dependency problems. I actually had a really hard time getting this thing running with like lots of no class def found, and it was getting quite a bit more difficult than I would have expected. And then the other thing is it tells you could use like Athena or Redshift, which like while the integrations are easy, like the draw for me with S3Tables was in like the simplicity of I just can create a bucket and then all my stuff works. And so I don't want to like incur additional dependencies, additional costs and configurations. And honestly, some of the like biggest challenges when working with many different AWS services is like IAM policies and permissions. It gets like complicated quite quickly. And again, I'm actually just trying to upload a Parquet file. And so like at a minimum, I would just want like a put object call or something. Okay, but then the other thing is, well, what about Python? So like we were talking about, Daft is a Python data frame library, and it's like backed by Rust. And so like the JVM is not in our stack. And so we like, the JVM has this custom runtime jar, but we don't have that. And like nothing on our stack uses JVM. And again, like taking a step back, at the end of the day, it's an Iceberg table and an S3 bucket. Like we shouldn't need a bunch of like custom logic to do this stuff. We just have to figure out how to get around this layer. So then let's talk about how Daft does this. And what I'm going to do is I'll start from kind of like data frame basics, those operations, and I'll unpack to how that actually will map down to the files. So the first thing is, how do you do reading with data frames? Well, whenever you do data frame operations, it kind of is like this. It'll start with a scan, and then we can compose operators on top of that. So I say data frames are trees, and if we look at it, it's just like building upwards, where we'll start with our data. We can initialize the data frame with a scan, like read parquet here, and then you can continue to compose your operators with the root ultimately being kind of your final projection. And then here's kind of a more abstract way to look at it. You have data, scan, filter. And what I say is they're fluent builders for logical plans. And so like if anyone here is like a SQL engineer, like you're used to seeing all these like logical plans on the inside of the engine, the data frames are like this really nice Python friendly syntax. But what's nice is like they're typed and they're very explicit and they're very composable. So there's a lot of benefits. And like I say, like SQL is not always that well typed, and it's not really composable. And so sometimes data frames are really, really nice for these things. So how do we read an S3 table? Well, the first thing we need to do is we need to map that table name to the latest Iceberg metadata file. We need to go through the service and figure out where that actual file is so we can get it, and then that'll give us all of our keys. Once we have that, then once we have our relative data files, we have the keys to the manifest, manifest list, and manifest, and we can go down and we can actually start getting our data files. And then we also use other metadata like a table schema, and that'll like help us prepare their in-memory data structure or operators so that we can actually start fetching some of this stuff. And then the last thing is like, well, we do just end up with S3 keys at the end of the day. And then so we just create a bunch of these things we call scan tasks, and then those can be distributed and they actually perform the get object calls. Okay, so how do you use S3Tables with Daft? It's actually quite simple. So we recently introduced these catalog APIs, and they're like a common and extendable interface, which allows you to abstract away any of like the details of actually accessing the data. And so here we'll just see we're importing the catalog from Daft, have our key set up, but then you can just create a catalog from S3Tables, and you can give it that table bucket ARN, and it knows like your region and stuff. And the implementation will actually create like a Bodo client to this new S3Table service, and then all of your requests will like use that ARN. So then you can do familiar kind of like generic APIs, like creating a table with like a Daft data frame, creating a table with like a Daft like schema and stuff, and it will handle all of the like, you know, how to call the service appropriately. Okay, so when we want to read one of these tables, we'll call out to our S3Tables catalog, and we'll say get table, and we pass it that identifier, just like you would with your like PyIceberg catalog. And this will give you back a Daft table, and we can .show to give us a preview. You can also .read, and that will actually like return a data frame object. But like, how did we get here? So like I said, when you go to read one of these tables, the very first thing we do is we take that identifier and we go and we call this S3Tables API, which is called get table metadata location, and that will give us that latest one. And then once we have that, we're now like in Iceberg land. And then so we can use PyIceberg to navigate the metadata tree to ultimately give us our data files. And then this is what that looks like in more detail and then mapped to the code. The get table call is really just going to S3Tables. It's going and finding that metadata file, and then we can just get object on that and run it through PyIceberg to then produce our scan tasks. Okay. Writing tables is kind of the exact like opposite direction, but it's also like a little bit more complicated. So when we want to write a data frame, it's the opposite direction. So instead of like starting with the data files and like scanning upwards and projecting things out, we actually want to collect all of that stuff at the end and send it off somewhere. So we'll see at the very end, we're composing things, we're building this tree upwards. We see write Iceberg, and we give it a destination. And we call the destination a sink. So it looks like this. We're going the same direction. We have data, whatever. We perform a bunch of different operators. We perform our transformations. We actually do our work. And then we end it with the write call, which we call our sink. Okay, so what does this look like in practice? So I have my points table, and then we have a method, which is .append. Again, like familiar PyIceberg style, we want to append this data. And you can put in different sources here. You put in a data frame, you put in file paths. And this should work, but unfortunately it doesn't. So what we get here is we'll get an error that's saying commit table is not implemented. And it's kind of funky, and you're like, well, like where is this coming from? And it's actually coming from the no-op catalog. So when you go ahead and just read an Iceberg table from its metadata file, you create what's called a static table. And the static table has no association with any kind of catalog. Yes, we are talking to the S3Table service, and yes, I have said the S3Table service is kind of like it. I mean, it is a type of catalog. It's not an Iceberg catalog. And an Iceberg catalog is responsible for actually committing the update to that table. So let's refresh. When we want to write an Iceberg, we do get that latest metadata file. We do our work, and then we actually put those new files to S3. But the most important thing is we need to commit our updated metadata file. You have to compute and say, here are all the things that have changed, write it, put it, and then commit. And that whole thing is the transaction. And the transaction is handled by the catalog, like I was saying, but particularly an Iceberg catalog. And so, well, because we're just reading this metadata file directly, where you have a static table, so we don't have an Iceberg catalog. Okay, so how can we get an Iceberg catalog from the S3Tables service? And like I was saying, the table service is not Iceberg REST. But if we do have Iceberg REST, then we can use a PyIceberg catalog to facilitate the transaction. Okay, well, we actually do have several options here. One of which is to enable these things that AWS calls like data integrations, and I'll show you what those menus look like. And we can use glue Iceberg REST. So when you create a table bucket, you'll see some kind of banner like this, which asks you, do you want to enable integrations with AWS services? And this will like enable access for like Redshift, Athena, but most importantly, it'll make it available in Glue and like Lake Formation. And when you go into there, you actually can like create a new Glue database from an S3Tables catalog, and you had to like map all of this stuff. And then there's also like dual permission models. So there's like not only all the like the actual S3 IAM permissions, there's also like Lake Formation has its own separate permissions. And like it was reasonably easy to get set up by just like admin privileging a bunch of things. But again, like the promise here is like in simplicity. We want to create a table bucket and move forward. So this is, if we enable that, this is kind of what our new stack looks like. So yes, we can talk to Glue Iceberg REST, but we now have 2 additional services. And like I said, introducing complexity that isn't necessary. It's still just Iceberg in a bucket. So this is what we were doing, and this is what we were recommending. And then AWS actually reached out, and they're like, hey, I know in December we like announced S3Tables, but actually very soon we're going to announce an Iceberg REST endpoint for S3Tables. So now, and this is kind of what the press release looks like. So this is less than a month ago. And what they did, if you look, is they just added a new endpoint. It's the same exact thing. You just do /iceberg. And then now you don't use an AWS SDK. You just use an Iceberg REST client. So all we had to do to update our code here then was append the Iceberg suffix, and then I just got rid of like Bodo 3. We're not using the AWS SDK anymore. We're just using PyIceberg's Iceberg REST implementation, and because it's AWS, we turn on SIG-v4 signing, and there's no visible change to the user. It's still just like catalog, you know, from S3Tables and give it that ARN. We just use a different client now. Okay, so let's try to insert data again. So like I was saying, when we want to insert data, we'll start with something like read parquet. So we'll have our data frame, and then we can append that data frame to our table. We have this, our points, our table object. The other option we have is S3Tables, like I said, that's our Daft catalog object. We could just like write table and give it the identifier and then pass in the data frame. Now, that worked because we are using that Iceberg REST endpoint. We did all of the work with the data files, and then we use PyIceberg to actually commit the transaction. And then if we want to read it back, because now, like, I showed you guys reading at the beginning, but like all that was doing was showing an empty table with some schema, but now we actually inserted some data, and so we want to complete the picture and read it back. So you can call, like I said, like just .read on one of these, one of the like Daft tables, and that's going to give you back your data frame. Or you can also read table and pass in your identifier. And that gives you back your data frame like that. The other thing is, because we have these like catalog objects, and they're kind of like a shared interface, we also have a session which allows you to like attach these catalogs and like maintain other state. And all of our SQL stuff goes through the session. So you can see I'm going to create a new empty session. I'll attach my catalog, my S3Tables catalog implementation, and then from there I can do select star from demo.points, and the SQL planner has all the necessary context. It looks at the session, says, okay, what catalogs are available to me, and it will go ahead and resolve that table name, and then behind the scenes it'll like hook into all of our existing reading and writing logic. Cool. So that kind of sums up the full story of reading and writing. And then this stuff we released a few weeks back at this point, like right after the announcement of the Iceberg REST endpoint. I just updated those 2 lines of code more or less, and we have that released. So we do support like reads and writes. You do like append, overwrite. You can also read by like snapshot ID. Yeah, and then another one that I think is really fun, that again, like in the name of simplicity here, is with just like a few lines of code. One, you can like create your table bucket, and then you can be running whatever data frame things you want, and then you can create a table from a data frame. And what it will do is just kind of split that up into like a separate like create table statement and then an append, and it just like can really like simplify some of your scripts. All right, cool. That's all from the description or details of things, and so I think we have a little bit of time to do questions if anyone's got anything.
Do you know if we can bring our own REST catalog with S3Tables? Like if we don't want to use their implementation and let's say bring in Polaris or something?
Yeah, I'm not sure about that. I could see possibly implementing one where it's shimmed, but I don't know. That'd be a good question for them. Yeah.
And so you mentioned S3Tables is not coupled with the table format. You can specify it. So apart from Iceberg, what other parameters can it take?
So Iceberg is the only table format that they have in there. And then also like noticeably there was no version number or anything.
Yeah.
So, yeah.
So, okay.
Yeah.
Even though it's configurable, it's tied
It's parameterized,
right,
but it's fixed.
Thank you.
How does the IAM authentication work with the REST Iceberg catalog on the S3Tables?
Sorry, did you say IAM?
Yeah.
Yeah. I don't know like the specific details. I feel like AWS might have some comment, but I think the IAM stuff is just scoped to. Well, okay, so yeah, you're right, because you'd be scoped to the keys, but then if you also want to scope possibly to the like prefixes of the endpoint, like the operators, I'm not sure. Yeah, because it's not part of the AWS SDK, so. AWS might know, yeah. I just work on SQL on Daft.
What's the difference between Spark and Daft?
Oh, yeah, that's a good question. Okay, so one of the primary things is the focus on like lightweight local. Like lightweight local is pretty important, and then the ability to scale up. And we also like integrate with Ray, which is nice. And that way you don't have like this like dedicated Spark cluster. You can just have like your Ray cluster where you can have like different jobs that aren't necessarily like ETL things, and then you can bring your Daft workload to that, like if you want to. There's a couple things like that. Another one is like no JVM, no Java dependencies. I think another one is like we're really focused on various like inputs in some of like the AI ML workloads, and so being able to like integrate well with existing Python libraries. I think you'll see stuff in there with like PyTorch, like PyArrow, NumPy. There are some like zero copy implementations as well. So yeah, just trying to integrate really well with some of the AI ML stuff.
Do you guys have a benchmarking? Like if you have done anything on the some workload, Spark versus Daft, which is faster and takes less compute?
Yeah, I think some of the other engineers will have more details on like the specific benchmarking. But yeah, some of that has been done.
We have some on the page, on our website.
Okay.
Cool. So thank you guys for coming to our talk. I am ChanChan. This is Connor. You can find our LinkedIns here and our emails if you have any questions for us. We have a booth upstairs on the 3rd floor. Connor, if you can stand up and show off your amazing shirt. We have these awesome Anti-Spark Social Club t-shirts. So you can find our booth upstairs. We're also raffling off an iPad, and we have the physical iPad, so we'll announce the winner at the end of the day. And I think that's all I have. Any last comments?
No, that's all. Thank you.
Okay, great. Thank you guys so much.